they will hear me talking tonight. Guys, this is what your homework's going to look like. Have you checked your homework yet? If you've already checked your homework, that's awesome. Make sure your name is on it. We're going to turn it in. Make sure you have shown all of your work. We discussed the work that needs to be shown as you guys are doing it. So, Mr. Holland will come around and collect with you guys. My guys just turn theirs in. I need everybody to go ahead and open up the front page on your worksheet. Student notes for number 4. Today, what we're doing is we're putting together everything we've talked about so far with the constant of proportionality. So we've talked about how to find it. We've talked about seeing it in graphs. We've about talking in tables, equations using it. Now we're going to put all 4 of those pieces together. So the first one we're going to do is a warm-up exercise. I'm giving you a scenario. I need you to write an equation in proper y equals kx format. I need you to fill out the table, and I need you to draw a graph. I will give you guys a hint. There's something missing on the graph that you should be adding. I actually know if I just put them on the last one, they didn't have it. You guys, we'll see how well you do on it. You can work together with tables. If you're doing 3 different things, I will give you guys 5 minutes. You have 5 minutes to work together as a table. Fill out all 3 pieces that are unique. Okay, actually, I have a really good question for Matthew on this one. He's like, how do I start on this? Where do I go? The first thing you need to do is mark your text. If you're marking your text, it's going to help you pull out the key information. So when I look at my scenario, the student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $5. So that gives us a lot. Now, if I've got this, where is the easiest place to start? Equation, the table, or the graph?
The table.
Table should be the easiest. Because once I've got the data in the table, it's going to make it very easy for me to find my constant proportionality, K, and then it's going to make it very easy to plot it on the graph. So if I would start at the table, that's going to be the best and easiest spot where you get all the information put down. Because it also kind of lays it out for me, right? If I'd also lay a t-shirt, how much am I going to get? 0. If I sold 10 t-shirts, how much money will I have?
50.
50. Do I need to put the dollar sign in here?
Yes, here.
Technically, no, because they put it here. But if you did, I would count it wrong. Okay? Now, the good thing is this is going up by the same interval, by 10s every time, right? So how much is this going to go up every time? 50. So another 50 puts this one to 100, then to 150, 200, 250, 300. Once I have this, it's easy to find my constant proportionality. Remember, my K always equals y over x. Do I know my y value? Yeah. 99% of the time, when you see a table, it's going to be x on the left, y on the right. If they do it this way, it's going to be x on the top, y on the bottom. Okay? There will be a very, very rare table that change that, but most of the time, you count on that being the case. So that means I can take any of these numbers except 0. Mathematically, we haven't figured out how to divide by 0 yet. So we can't do that. But any of those other entries, I can use any of them. It doesn't matter. I prefer to use the smallest one because that's going to make the numbers easiest to do. So I would just say it's going to be 50 over 10. 50 divided by 10 is 5. 5. I now have my K value. Now write an equation. Yes, because I know y equals Kx. That is the definition of constant proportionality. But I now know my K value is 5, so I can say y equals 5x. So I have to have the dollar sign there. You don't have to. I highly recommend it because you know that constant of proportionality has an associated unit, which gets us to the graph. If you guys gave me this graph, I would cut it off because it's missing something very important. My guys don't answer because you already know the answer. What's it missing on this Vandermeer sign? Anybody know? Yes. It doesn't have y in it. Put those down. That's actually, I wouldn't count that off anyway. There's another piece that's missing. No, we can't do that yet. We have to put the date in. Go ahead, Allison.
Labels.
The labels. I don't know what those things are, do I? What's 1030 50? What is that?
The shirt.
What about the shirts? The number of shirts. So this is the number of t-shirts. Oh. And what is the other side? The dollars donated. So this one is our dollars donated. So I would add in your labels as well. Make sure you understand what it is you're talking about. Once you've done that, now you can plot all of your data. They've given it to me right here in the chart. So I know it's at 0, 0. At 10, it was 50. At 20, it was 100. At 30, it was 150. And keep going up. Once I have those dots on, you must use a straight edge. I cannot draw a straight line without a straight edge. You guys cannot freehand it. I can't freehand it. I mean, I'm a good math teacher, but watch what happens when I try to freehand it. See the waves in there? Like I totally missed that point when I tried to freehand it. It's not going to work. So you must use a straight edge. Is that clear? Jack? Are you sure? Okay, so I'd wake you up. You also should put an arrow at the end because that relationship's going forever in that direction. Does this make sense? Asher?
Will we get points off if we freehand it?
Yes.
Oh,
I will take points off. I can't speak for Mr. Vandermaiden. I will take points off.
yeah, I felt my homework.
Yes. Depends on how big the problem is. If this were the problem and you're getting rated on all 4, this would probably be a 10-point problem. I would probably take off 1 point. I mean, it's not going to be huge, but you need to use a straight edge. Because the whole key, guys, on a line, the best benefit of a line is I can make predictions. But if my line isn't accurate, can I actually make predictions on it? No, I can't. So you've literally ruined the purpose of a line if you're not using a straight edge. So yes, it is actually really important to do so. Any questions on any of those 3? Okay, so today you'll see it's going to go pretty quick. Our next set is basically the same, but now, oh, I skipped one. Did I? Okay. Now they want you to actually look at it. Bottom of the page, take a look at what we just did and answer these questions. What we've given you is data. We want to make sure you understand what that data means. So this gets into the meaning of what you've just done. So I'm going to give you guys about 3 minutes of conversations at your table about what each of these are. Talk about it as a table. Make sure you guys all agree. Go ahead and start. Okay, let's go ahead and answer these questions. Describe how you know that the above situation is proportional. And 2 really good answers. Either one. Anybody have an answer for how you know it's proportional? Awesome. That's my favorite one. We're talking about proportions, the easiest way is to plot a graph, and the line goes to origin. If the line goes through origin, by definition, it is proportional. And just for the record, what is origin? That is that 0.00. What is the second way that I can usually do this? They have what? There's one other really good one. Asher?
You get the same amount. You get $5 for every shirt each time, so it's the same amount of money for each shirt.
Okay, you're right there. You're just not saying the math terms. Can you put that mathematically? What is it I'm looking for? Or what is it I see that tells me it is proportional? It stays constant. So there is a constant of proportionality. So if I have that constant, then I know it's proportional. As long as I see that same constant at every data point, it's proportional. Does that make sense for everyone? Yeah. Okay? Find the constant of proportionality. So we kind of did that already, right? I can take any of the data points I took, and I'm just going to write the generic formula up there and make sure everybody understands it. We took the point of 50 and 10, which simplified to 5. So what is my constant of proportionality? 5. Okay, what does the rate of change represent in this situation? So what does that 5 represent? Maya. Okay, I would just flip it and say they donate $5 for every T-shirt.
How many money per shirt?
Yep. For every T-shirt. Okay. What does the ordered pair 1050 represent in the context of the situation then? Yes.
Every 10 shirts, $18.
Perfect. Every 10 shirts, T-shirts, they donate $50. And if the student council sells 80 T-shirts, how much will they donate to the shelter? Someone hasn't answered yet.
I have this answer. $100.
They will donate $400. That was the point that you happen to be right. Or didn't follow it wrong. So the easy way to do that is instead 80 times 5, that would make sure 400.
I showed my work.
Questions on any of those? What's happening in those graphs of the real world situation?
Yeah.
They actually mean something, and we're trying to make sure you can understand and interpret what that meaning is, so it's not just a bunch of numbers. Okay, let's go over to the next one. On this one, all they did is use an equation. But that equation gives you some really important information. You can use that equation along with the table to be able to figure out your verb description so that you can the table and the graph. So this one might be a little bit harder because they have told you the situation. You need to interpret it from the material. So we give you guys 5 minutes to do this one. You got all 4 boxes to fill in, 5 minutes to work as a group. Okay, on this one, it was a little bit more complex. Tell us what's happening. But literally, from my equation, just gives me the point to enter in everything else. So, just like as you asked me last time, where's the best place to start? Quite frankly, the best place to start is on the table. Now that they've given me the equation, remember that my table is set up x and y, they gave me the values, right? So should I be able to find my y?
Yeah.
Substitute the value in. If I put 1 in for my x, what is y?
3.
3. If I put 2 in for x, what's my y?
6.
You see the pattern?
9, 12, 15, 18, and 21.
Once I have this, now you should be able to fill in your table because or your graph and all the ordered pairs. Just to make sure everybody understands, if I translate this to an ordered pair, my x always comes first and y is always second. So that ordered pair is 1, 3. I'm not going to make you write that. That's just to make sure everybody understands. Okay. But now that I have my data, now I should be able to go straight into my graph. So at 1, it's 3. At 2, it's 6. Technically, I can draw a line now. Do a third one to make sure. Now you can put your ruler down. If you can't line up all 3 of them, you made an error in your graphic. And now my ruler should go down. I should be able to draw my line straight through there. And it should go something like this. Again, here's why I hate not having a ruler. My line's off as hard as I try. If you have a ruler, it should be exact. The graph, believe it or not, is actually the best one of all of this to tell you your verbal description. Because on the graph, I can say, okay, we're talking about Jack's Halloween decoration. We're talking about how many hours it takes, how many pumpkins he can paint. So from that, you guys give me a full description of what this problem is about.
Every so many hours.
Allison?
Jack spends 1 hour decorating every 3 pumpkins.
Okay. So I probably would have turned it around. So Jack's Halloween decorating can decorate 3 pumpkins every hour. But you could have said it your way as well. That's absolutely fine because they didn't actually give anything that verbal description about what it was. So Jack's Halloween decorating and actually this color is painted, can paint 3 pumpkins every hour. You could have said that in any number of ways. You see that 3 pumpkins and square. It's a question on this one. I'll be honest, this was actually the harder of the 3 so far.
Really?
Yeah. If you don't understand the concept, absolutely, because they didn't tell us what was happening. Okay, so now we've got one more to do. And this one, they only gave us 2 data points on the table. Everything else. We've only got 5 minutes in class, so while you guys are working on this, we're going to hand out your homework. And then I'm going to just throw this in here while we got the video going. You may have noticed, we've been talking proportions for the last 3 weeks, right? And this is doing everything all together, isn't it? Uh-oh, that sounds like everything we need to learn. We don't need to learn. How do we actually learn it? And we want to definitely do it in this class. We're going to take a quiz. Understand this? Guys, learn out of the corner over here. Oh, we're taking a pop quiz? Yes, we're taking a pop quiz, I'm telling you, 4 days before. Ooh, what a pop quiz.
You popped out later.
Okay, I have 2 minutes left. Go ahead and knock this. Okay, since they gave us the table, that's where we need to start. You kids, when you do this, start with the concept of proportionality. They've given me an X and a Y right here. Technically, if you know, be confusing the one, I always like to do the lowest number they've given me, because that's going to make it easier to simplify. Remember, my K equals Y over X. It all comes down to these basic equations of proportion. I now know that K is 9 over 6. Can I simplify that?
Yeah.
Yeah, so I'm going to multiply 3, which is going to give me 3 over 2. So, at 2, what is my mile?
Three.
3. And 4 was my mile. Thanks. Once you've established that pattern, fortunately, time here, right? I still want to go by here. 12 and 15. Point. You'll have to listen to the video and get the part of it. Okay, guys, sorry, the class is stopping. All we need to do now is go ahead and mark these, make sure you're paying attention to the interval. So 2 it's 3, and 4 it's 6, at 6 it's 9. At this point, we can now draw a line, draw 3 data points, to look up something like this. We now also have our concept of proportionality. So I can now say that y equals. Now we're getting into our advanced math. That's acceptable as an improper fraction. However, if you wanted to rewrite this as y equals 1 and 1 or y equals 1.5x, any of those would be acceptable as answers in there. Again, now we're looking at what we're talking about. So, the graph gives us the best idea for what we're going to talk about. We'll put the verbal description on this. We're talking about a jaguar's daily movement. So our verbal description is a jaguar can move. And we found 3 miles every 2 hours. That gives us our verbal description. have the verbal, you've got your equation, and your table's filled out, and we've graphed it. Again, don't forget to use a ruler or straight edge, and make sure you put the arrow at the end. Good luck, guys. I don't think I have homework.